Organic synthesis is the systematic preparation of compounds from readily available materials. SN2 reactions and nucleophilic substitutions in general have been widely used to prepare those materials. They are very useful to introduce functional groups in a molecule. Organic synthesis has allowed chemists to produce and synthesize compounds such as pharmaceuticals, pesticides, and polymers that we use in our everyday life. Here you have some of the examples of the reactions that we can use, starting with an alkyl halide, that we can introduce so many different functional groups that they can be later used for further transformations. Here you have what we start with, what we end up with, and here you have the reagents that we will use in every single case. So by displacing this Br in this particular case, we would be able to introduce many different functional groups. Now, this process that looks as something very intuitive, right? You have to figure out what is the reagents that you need to use to end up with an alkyne in place or an iodine in place, that we can also do it backwards, right? So you know that you want to have, for example, an azide in place. So you know that you have to start with a Br, right? And then you can simply displace it with N3 minus used as a nucleophile, right? So you would use Na3. And in this case, it doesn't matter because it's a primary alkyl halide, but in case you have a secondary alkyl halide, then you know that you will get inversion of the configuration. So all of those things, you have to keep them in mind when you are doing synthesis in organic chemistry. Now, this process seems very intuitive for us now, but the person who really came up with this idea and who really wrote on it, that's E.J. Corey, and he won the Nobel Prize for his contribution to organic synthesis and particularly to retrosynthesis, which is this idea of thinking what you need to start with to be able to end up with the product that you want. So that's called retrosynthesis in organic chemistry, and he won the Nobel Prize in 1990. So here you have some other transformations. We can, depending on the nucleophiles that we use, we can end up with all these products. And so this is exactly what I was talking about. So we know we have to start with an alcohol here at the end. So what is the starting material that we need, and what reagents are we going to be using? This is what we called retrosynthesis, meaning thinking backwards in organic chemistry. And so if we go back to the previous example, we know we have to start with an alkyl halide that will be displaced by an OH minus, and that will give us the OH that we want in place.